Hi everyone, my name is Cem. I am a student of Professor Jim Falny. In our research, we are interested in the electromagnetic fields emanating from the chip and the board on which the chip is implemented. And our ultimate goal is to determine whether this chip is authentic or not. Since the board itself is linear, in the first step, we solve the Maxwell's equations on this board to obtain an S matrix, which will represent this board in the upcoming circuit simulation. So in this S matrix, every connection that can be made with this board, such as SMA connectors, wire bonds, or even external plane wave electromagnetic field generators, are all represented as individual ports. Once we have this S matrix, in the second step, which is my responsibility, we prepare the circuit simulation, which is the chip we are interested in, and we import this S matrix into this circuit simulation. We make the necessary connections with the board and the chip that will represent the reality, and we conduct a time domain simulation. We do it in time domain because the chip is in general nonlinear. After the simulation, we will obtain the total voltages on every port of this board. We then compute the Fourier transform of all of these voltages to obtain frequency domain voltage of the fundamental frequency, second or third harmonics. After that, we can invoke microwave theory and compute Z matrix from the S matrix. And once we have the total voltages and Z matrix, we can then compute the incident voltage on all of these ports. And the really good thing about these incident voltages is that we can feed it back to the EM simulation and calculate all of the necessary radiated EM fields, which then we can measure in the third step. My other responsibility is making necessary communication with the Professor Sertal's group, which handles this third step so that we can make sure we are simulating and measuring the same phenomena. Thank you for listening to me.